What's going on? Today we're going to talk about Linux fundamentals. We're going to go over all of the fundamentals, all of the foundations of Linux that you need if you want to start in cybersecurity or if you just want to go advanced with Linux. This room or this video is using TryHackMe rooms. So we will get into that later to answer the questions. Now first, let's start with the fundamentals. I'm going to explain here, and when we need to apply something practical, I'm going to switch to my virtual machine, which is here. Okay, so Linux fundamentals, how can we start with this? What we would start as a Linux fundamental. So basically the first thing, let me change the color. Okay, the first thing in Linux is the echo command. So what would echo do? It would output whatever you type into it. So for example, if I take the prompt here and say, for example, echo hello, to type, it would just return echo hello, right? Whatever you put here, you can also put that in between double quotes. It would say hello. Now, if you want to get more information about the inner workings of hello, you can just type hello and the flag -h. Oh, man echo. So just type man echo. And see here all of the flags used with this command and a description of it. As you can see, we have the flags, right? Don't output the trailing new line -n -e -help for the help. And of course, you can see the description, echo the string or the strings to the standard output. So, which brings me now to the next thing on Linux. The next fundamental aspect is the man pages. Technically, man pages give you information about every command on Linux. So for example, all you have to do is just to type man and the command. For example, man cat will give you all of the details about the flags, the options you use with the cat, and the description. As you can see, cat is a command. As a command takes an option, right, and the file. So the file is the file that you would like to display its content. So description saying is concatenate files to standard output with no file, or when file is read standard input. And you will see all of the flags used with cat. For example, if we just type ls to see the current content, say touch, say echo, hi, and append the content to a new file. Just ignore what I'm typing now. To just say test.txt. Now, if I want to see the content of the test.txt, I would type cat test.txt. Okay. Now let's get back to the board. The third thing is we learned how to use the man pages. The third aspect is the cat command. The cat command, as we said earlier, is used to display the file content. So basically, we would type here display file contents. All right. Now, the third thing about Linux is the ls command, right? So ls, and most of you know what ls does, lists, files, and directories. So for example, if I get back here, and if I want to list the files in the current working directory, I would type ls. I would see we have shiba2 and we have test.txt. Now, ls has other options. So if you want to display all of the files, the hidden files and the hidden files and the non-hidden files, the hidden directories and the non-hidden directories, you would type ls-a. As you can see, everything that starts with dot is hidden, right? Now, if I want a long list displaying the nature of every entry, I would type ls-la. So LA, the L here, displays a long list. The long list contains the nature of every entry here. So this one, for example, is a file. This one is a directory. No, this one, sorry, is a directory. As you can see, it starts with D. This one is file. This one is file. That's how ls works. Now, let's get back to the board. And so here, we have also the basics. We have touch. So touch creates a file. That's it. Creates a file. And probably you've seen how I use that in creating the file test.txt. Nope, I didn't use it. Okay, we can just use it here. Very simple. So touch test2.txt ls. We have test2 now. Simple, right? Okay. Now let's get now to the first thing that would be considered Linux, right? Here. So here we have executing binaries. Or in Windows, it could be called executables, right? Executing binaries. So if you get back now, you see here we have Sheba2, which is a binary. Now it doesn't have .txt, it doesn't have .png. Most probably it is a binary. So how would we know the nature of the file? Technically, we would type file and then Sheba2 displays the nature of the file. So the file here is, as you can see, setuid elf 64-bit executable file, runs on 64-bit environments. So this is a binary file. Okay, if I type file test.txt, I will get different outputs saying ASCII text. So the first thing is you use the file command to see the nature of the file, and then you decide how to go further with it. So coming back to the binary execution. So coming back to binary execution. So we have the relative path and the absolute path to take into consideration when you want to execute binary. So we have first the relative path. I'm not sure this color is helpful. Let me change the type. Okay. And we have the absolute path. Okay, so absolute path can be denoted, or we use absolute path by defining the full path of the variable, of the binary. For example, say we have a binary called, in our case, it's called Sheba1. So we can execute Sheba1 by saying home Sheba, or home, yeah, Sheba, defining the user directory, and the binary name, which is Sheba1. Okay, that's executing a binary with the absolute path. Now, with the relative path, we use dot Sheba1 or dot Sheba1. Okay, or the third option is using, I'm going to explain every one of these, Sheba1. So that's if you want to use the relative path. That's if you want to use the absolute path. Now, what is the dot over here? So dot means executing the binary from its current working directory. Okay, so if Sheba1 is in home, okay, it will execute Sheba1 from home. If Sheba1 is somewhere else, if the current working directory of the Sheba1 is somewhere else, it will execute Sheba1 from that place. Dot dot, it will execute Sheba1 from the directory before the current one. So say the current one is home Sheba. Okay, saying dot dot Sheba1 will execute Sheba as if it was in home. If it wasn't in home, it will give you an error. Now, this symbol slash Sheba1 is executing Sheba1 from the home directory of the user. So if the home directory of the user is Sheba, it will say this one is equals to home Sheba Sheba1. So let's take an example from the machine here. So say ls, okay. So now if we type pwd, pwd displays the current directory, which is Sheba2. Now if I execute, if I am about to use the relative path for Sheba2, I'm going to type dot Sheba2. Segmentation fault, but the binary has been executed, right? But there was an error, that's why it couldn't be executed. But that's how we use the relative path in this case. Now, if I want to use the absolute path, I would say home wait a second. Okay, pwd. Okay, so home Sheba2 Sheba2. Okay, so using the full path is not always possible all the time. So that's why we use the relative path. Okay, so that's for binary execution. Coming back to the board. All right. Now, say we want to changing users. Changing users is done by using a command called su. So you put su here, okay, and then we put the user to which you want to change. So here, user. Now, if you say only su alone, it will change to the root user. Okay, so for example, su root will change to root, right? But we don't have the root password now. It will give an authentication failure. Su alone will also change to root, but not possible now because we don't have the password. Su Sheba3 will change to Sheba3, giving that we have the password for Sheba3. Okay. All right. Now let's go and explain the Linux operators. So let's remove this. Okay. So for a second, we type Linux operators. So the first one we have is the and. So that's the first one. The second one is one and, single and, right? The third one is $sign. The third one is, or the fourth one is pipe. Not straightforward. Okay, so the semicolon, and we have the one arrow, the double arrows. Okay, so what does every one of these operators means? For the first one, used if I want to use to execute two commands. right? I'm gonna touch into that after I finish. Now, the second one, single ampersand. Okay, so here we have double ampersands. The single ampersand background a command, right? We will take an example after I finish. Now, the dollar sign used for how can I say it? Creating environment variables, right? And echoing current environment variables. So you can use that to create environment variables. Now we have the pipe. The pipe is similar to AND, the double ampersand, right? Sorry, the pipe here is different. The pipe is taking or piping, taking, let's say taking input from the first command, right? And use that input as an output. Sorry, use the input. So here is the mistake. Output. Take the output of the first command and use it as input for the second command. Now we have the semicolon. The semicolon is similar to double ampersand, right? So used to execute two commands, but it doesn't require that the first command is successful. So say we have something like DC, DS, and then we put semicolon cat. Okay. So if we use the semicolon here, right, Linux will not give you an error, right? The interpreter will not give you an error. Why? Because the first command, although the first command is not correct, right, it will still execute the second command. Now, if you use the DS double ampersand cat, it will not work because the double ampersand requires that the first command is correct and the syntax is valid, or the command is valid before it executes the second one. Now, the arrow here used for output redirection. The double arrows is the same, but the difference is the double arrows will not erase the content of the file to which you are directing the output. Let's explain more. So we have here executing two commands, right? The first one is ls. So we have ampersand. I need the ampersand now. Okay. And say echo hello. So as you can see, we listed the files and we output hello. Now, if I say ds, right, and echo hello, this will not work. Why? Because, as I said earlier, the double ampersand requires the first command to be valid. Now, if I use ds or ls, say semicolon, and then echo hello, you see, it worked the same way the first one worked. But if I use now ds echo hello, it will still echo hello, right? But first, it showed me that the first command is not valid. That's the difference between the two. Okay, now, the single ampersand. The single ampersand is a background. Say you have a command like sleep, right? And after 5 seconds, right? And you don't want to hang or freeze the shell here. So what we would do, we would type ampersand, and this command will be executed in the background. I will not type enter now because I don't want my machine to sleep, but that's the explanation of it. Okay, dollar sign. Let's talk about the dollar sign. So the dollar sign, as I said earlier, is used to most probably or most of the times is used with the environment variables. So if I said echo, one of the most common environment variables is the path environment variable. as you can see, it has showed me the value of the environment variable path. And dollar can also be used with normal variables. For example, if I say touch say user, right, and then I say echo user. So here the user is, or the user environment variable displays or stores the information about the home directory. So say I want to display the content of the user environment variable. The user environment variable stores information about the current user. That gives me Shiba 2. Now, how can I create environment variables? Okay, with the dollar sign, I can use export command, okay, and name my environment variable. Okay, for example, I say test equal test. Okay, now environment variable with the name test has been created. If I want to see its value or output its value, I would say echo test equals to test. Okay. We can also use echo to display home, which is information about stores information about the home environment variable, right? All right, let's talk about now the pipe. So now we have covered the double ampersand, dollar sign, now the pipe. The pipe is, as I said earlier, it takes the output of the first command and uses it as an input in the second command. So, for example, say let's create a file called, or let's say echo, this is test, into a file called pipe.txt, cat pipe. This is test. Okay, let's demonstrate an example with this file. So, pi said cat pipe.txt, right? Now, before using the pipe, you have to imagine, or you have to understand, you have to know what would the output of this command would look like. So, I know that by typing cat pipe, it will give me, this is a test. Now, pipe, okay, say grep, we will touch into grep later, grep, say test. What happened? Now, cat pipe.txt, it has shown this is the text, this is a test, right? Now, pipe has taken this is a test and as an input to the grep command, right? Grep command looked for the test string and gave you here that test really exists in this file, which is here. That's the use of pipe. Okay, semicolon explained. Now the row operators. Okay. So as I said earlier, used for output redirection. But the difference is when we use echo, for example, let's use that on this file. We have a file called pipe, and the contents of it is this is a test. If I said echo double arrow, right? For example, echo hi to pipe. This will redirect this, right, and append it to the pipe.txt so that pipe.txt would look like this. Cat pipe. This is a test, and hi has been appended to the next line. This is the case with double arrows. Now, if I said echo single arrow hi to pipe, what will happen is, as you can see, the full content or the whole content has been replaced. So instead of this is a test And the next line, hi, only hi has been created in the file. Why? Because that's the function of the single row. All right now, let's dig into file permissions and how to how to deal with the owner of every file and directory. All right, let's erase this one and let's talk about file permissions and operations, say. So file permissions and owners. So as most of you know, guys, that every file on a Linux system or directory has an owner and a group. So say we have a file called test, right? txt. This file has first owner and a group. Most of the time, the owner is included in that group and many other users. The group is a group of users, right? So say, for example, if the owner is, say, user 1, and the group is, say, what do you want, HR? So HR here might contain user 1, might contain user 2, and user 3. So user 1, user 2, user 3 has certain permissions and rights on this file. Why? Because they are included in the group assigned to this file. Now the rights and permissions, you have the read, for read, you have write, and you have execute. Of course, the write is denoted by W, execute is denoted by X. All right, so let's explain that in the command line. So ls-la, let's see here. Let's take an example. So we have a file called test2.txt, right? As you can see, the user is Shiba2. The group is Shiba2. Let's take a look at the rights and permissions. So as you can see, we have here 1, 2, 3, right? Three slots. Here we have 3 slots. We have 3 slots. The first one have 1 empty slot. Here we have 1 and we have 2. What does that mean? The first 3 slots are for the owner. So the owner here is Shiba2. Shiba2 means has rights and read and write on this file. They can read the file, they can modify the file, but they can't execute it, right? Simply because the file is not an executable, it's text file. So now the second slot is for the group. The group also can read and write, but cannot execute. The third slot is for everyone other than the owner and the group, right? Everyone in the web server context or web pages context is you as a visitor. So here, everyone else has only read permissions on the file. So if we come back to the board, explain the order of that, change the color to make this things clearer. So the order is we have the read, we have the write, I have the execute. Okay, 3 slots all the time. So let's get back. Okay, now let's talk about, say we want to change the owner or the group of a certain file. So here we would use a command called Cron. Cron changes the user or the group or both of a file. For example, I have here test.txt, right? We can change the permission, the owner of this file from Shiba2 to root, for example. So Cron Shiba or Cron root, and keep the group as Shiba2, for example, to test. So in this case, as you can see, the current user cannot execute Cron, right? They can't use it. They don't have right to do that. If they are in the sudo group, we can use sudo, get the help of sudo to perform this. Now, here we have to put the password of Shiba2, which is pink UFTW. So see here, Shiba2 is not in the sudoers file. So this means that we can't even use the user, or the user cannot run the command in an elevated prompt. So let's go to temp ls-a. So all the files here are under the root. So technically, most of the time, if we want to change the owner of a file, right, we have to do it to a user which is below that owner, below that user. So if I want to change the owner of this file, right, from Shiba2 to something else, here I have to be the root, for example. All right, now let's talk about how to change the owner of a file. So we have a file here, for example, called test. As you can see, the owner is Shiba3 and the group is Shiba3. To change the owner of the file, we use the Cron command, right? And then we use the destination owner, or the owner that we would like them to have the ownership over the file. For example, from Shiba3 to Shiba2, and the group could be Shiba2 test. But as you can see, the operation was not successful because the user Shiba2, we don't have rights to execute this command, right? So this means that it's recommended, if you want to play with the ownerships of the files and directories, it's recommended to be the root user. Okay, so simple as that. Cron the user that we would like to have their ownership over the file and the group. Sometimes we would also want to change or only change the owner of the file, right? Not the group. If I want to change the ownership of a directory, I would use Cron and -r to change the owner of the directory and all of the subdirectories. So Shiba2, Shiba2, and here the destination directory. So here test directory, for example. Okay. Now, since we are not root here, I'm going to explain that on my machine. So create a file called touch test.txt. Let's view the permissions. So test, as you can see, the owner is me and the group is me. So the permissions are read write for the user owner, read for the group, and read for everyone else. Now, if I would like to change the owner from me to root, I would say sudo -r root, and the group is root to test.txt. Provide the password. Look at that. Now the owner has changed. Now let's create a directory now. Say sudo make directory called test1 and cd test1. Let's create a file under this directory called test1, test2.txt. Okay, as you can see, now we are inside the directory test1. Test2 has root as the owner and the group. If we get back, okay. Now the directory test1 has also root as the owner and root as the group. I would like to change the ownership of the directory and the file inside that directory. So I will do sudo cron -r the user and the group and type the name of the directory. So ls-la. See now the directory ownership has changed to my name and the group. If I cd to that directory now, see the ownership of the test file, as you can see they have changed. Okay, that's about changing the owner and the group. Now let's go back, or let's switch to file permissions. Let's take all of this. So file permissions, as we said earlier, we have the read, we have write, and we have the execute. And the command to change the permission is chmod. And here we provide 3 digits, right? Let's change the color. So digit 1, digit 2, digit 3. What are these 3 digits? These 3 digits are used to specify the exact permission that will be applied on the file. For example, digit 1 denotes the file can be executed. Digits 2, the file can be written to, like W, right? Digit 3, it means that the file can be both executed and written. Digit 4, the file can be read. Digit 5, the file can be both read and executed, so read and execute. Digit 6, the file here can be written to and read both, so it is read, write. And lastly, we have 7, which is the file can be read, written to or modified, and executed. So if you memorize these or understand them, you'll be able to use or manipulate the permissions very easily. Let's take an example. Change the color to, okay. An example would be, say, chmod, okay, 341. What does that mean? It means that the file, the first 3 here, or let me delete this, right, to make things clearer. So here we take an example. An example command would be chmod, say 342 and test file. So what will happen on this file? So we have first, the first digit denotes the permissions of the owner or the user. The second one denotes the permissions of the group. The third one denotes the permissions of everyone else or others. So what does that mean? In our example, this means that the owner, as you can see here, the owner can both execute and modify on this file. So the owner permissions here are read, so 3 execution and write. So here it will be with dash because no read permissions, W and X. The group, as you can see here, the group can only read the file. So we write read dash dash. Others can only write on this file. Okay. Another example would be let's change the color first. Okay. So say chmod 777, right? Test 2.txt. So here we have, let's include the owner permissions. The owner permissions here are, as you can see, 7. 7 means everything. So read, write, execute, the owner. Now the group also read, write, execute, read, write, execute for the others. Okay, example on the command line. So switch to the virtual machine or the lab. Okay, ls-la. So the file test. Let's look at who is the owner. The owner is Shiba3 and the group is Shiba3. The type of the entry is directory, right? As you can see, the permissions are the user can do everything. This is 7. The group is 7. And here we have R and X, which means only read and execute. Read and execute denotes 5. So this file has 775. Okay, I hope the permissions section is clear. Now let's move on to something else. Let's talk about deleting files. Deleting files. So as most of you probably know that deleting files can be achieved with rm. So rm is the command that's used to delete files, right? But if you want to delete files, you would use rm file. Directory rm, here you use -r to delete the directory and all of its subfiles. Now this is very simple, right? Most of you know that. Now let's talk about moving files and DIRs. So moving files DIR is accomplished by using the mv command or move. The mv command takes source and destination. The source is the file that you would like to move. Say we want to move file 1 into a destination. Say it is in home user file 2. So this one will move the file 1 from its current directory and put file 1 in home user file under the name of file 2. So you can also use move command to change names. Okay, so for example, we can use move like that. mv file 1 file 2, right? So technically I didn't change the location of the file. I just changed the name from file 1 to file 2. Okay. Now let's jump to the fun part and answer the questions of the room. So technically this is the room 2. Okay. Now some of the parts are easy. Let's jump to the ones here. So how would you change the owner of the file to paradox? So with chon paradox as the user, the file is file. What about the owner and the group of file to paradox? So here we change the owner and the group together. So chon paradox as the owner, the group is paradox, and the name of the file is file. What flag allows you to operate on every file in the directory at once? Recursive -r. Permissions. So what permissions mean the user can read the file, the group can read and write to the file, no one else can read, write, or execute. So read the file, it is 4. The group can read and write to the file. So we have read and write, which is 5, and no one else read and write. No one else can read, write, or execute, which is 0. Wrong? It's not 5, it is, I guess, 6. Okay. What permissions mean the user can read, write, and execute the file. The group can read, write, and execute the file, and everyone else can read, write, which is 3/7. Okay, RM. What flag deletes every file in the directory? Recursive R. How do you suppress all warning prompts? Let's get the help of man RM. You think attempt man RM. Okay, let's see the flags. So dash for ignore non-existent files and arguments, never prompt, which is dash F. So this is the required flag. Suppress all warning prompts, dash F. Okay. Advanced file operations, MV. How would you move a file to temp? So MV file to temp. If you don't want to rename it, just mention the destination directory. Okay, and that's it for the Linux fundamentals 2. Now Linux fundamentals 3. All right, let's talk about now copying files and creating directories. So copying files. And creating directories. So most of you know that we can use a command called cp to copy one file, right, from one place to another. So file 1, copy file 1 to a destination where it is in home, user, file 1. So file 1, or an exact copy of file 1, will be created in this directory. Clear, right? Now, also we can use cp to copy directories. If I want to copy an entire directory with its subdirectories and files, I would use cp and here -r, and then we put the directory. Say it is /temp. Copy everything in temp to say home user temp. Okay, now let's talk about creating directories, or yes, so using make dir. Very simple. And then you put the name of the directory. Say it is dir. Okay, simple and easy. All right, let's talk about now the symbolic links and the hard links. So you know there's symlinks with hard links. So a hard link is a hard link, right? So hard link creates an exact copy. So if I said ln, this is the command used for creating links, ln file 1, file 2. Okay, now file 1 is the original file. File 2 is the linked file. So file 2 now contains an exact copy of file 1. Okay, and whatever change is happen on file 2 will be replicated to file 1. This is hard links. What about symlinks? So symlinks can be created by using ln-s file 1, file2. Okay, now the case here is the same. File2 will have the exact copy of file1, but in this case, file2 is only a reference to file1. So, meaning that actually, in reality, it doesn't have any content inside of it. Okay, it's only a reference, and most of the time you would see, if you, let me demonstrate with an example better. So clear list.la. So as you can see here, file 4, we have in a row, we have file 3. This means that file 4 is a symlink to file 3, and we have the L here. But in the hard mode or in the hard link, as you can see, file 1 and file 2, actually I have linked them together with file 1 as the original file and file 2 as the backup file. But there is no relation as a referencing, right? Because it's hard linking. So that is about hard links. Let's talk about now the find and the grep. So find with grep. An example, find can be used to find, just to find, right? Find files, find directories in the system. For example, I said find, and here I define where I want the system to look. For example, slash, meaning that it will look in the entire OS. Okay, dash name. Here I'm giving find the name of the file. For example, I want to look in the OS for every file that contains the name or that has the name, say THM. Okay, and then I would output all of the errors and prompts to dev and null to ignore the errors. I don't want to see them in the prompt. So dev. This is an operator. This is 2. Not so nice, but will do the job. Okay, that's fine. Now find here will return all of the files that has the name THM and in the OS. Now technically find requires you to have permissions over the directories you are looking in. So for example, find now will look in the entire OS. Say it now arrived to the directory etc. Okay, it will look now in the etc. For example, during the pipeline, in the pipeline. So it arrived at etc and it's looking for every file that starts with THM or has the name THM. Now, if you don't have permissions over or if the user doesn't have permissions over the etc directory to read, it will give you permission denied. Okay, but it will be ignored by this. Okay, now what's the difference between find and grep? So grep is different. Grep is used for pattern matching. So you would use a grep, okay, and here you use regular expression. But most of the time, the simple use of grep is using string. So string, and here file. So grep will look for the string here in the file. Okay, say for example grep hi in file 1. So to look for hi in file 1. Let's demonstrate with an example. Okay, so say I want to find the password file in the Linux. So I would use find dash name passwd to dev no. So as you can see, there are 2 files with the name passwd3 etc user bin, and it will continue down the road if it finds other matches. Of course, you can also specify the type of the file you're looking for. So in my case, -name, -type F, here you're looking for files. -type D, you're looking for directories. You can specify the type using the -type. And of course, you can use the man page, man find, to see all of the flags on this command. Okay, let's talk about the grep. So previously, we got file1, it contains hi. Let's create more content on that file. Cat echo. This is Linux tutorial into file1. Okay, now grep. Let's say I want to look for Linux in file1. You see now it outputs the content and the line, or the line that contains the word or the string or the regular expression. Now, sometimes you want to use grep in this way. You would use grep and combine it with another command using the pipe. So, for example, echo this is Linux tutorial and grep tutorial. So see here, tutorial has been highlighted. Grep and find have an extensive use, more than just we have outlined. But you can also use the man page to find more details about the flags and the options of these commands. Let's switch now to the board and demonstrate some important files and directories and the meaning of them in the Linux system. Okay, so the first one is /etc/password, passwd. So most of you know that this one is for storing user information, right? All users on the system. The next one is etc shadow. etc shadow is or contains all of the user's password hashes. Okay, so most of the time, if you're doing pen testing, you would want to try to read these files. Okay, if they are configured or they are misconfigured, you will be able to read them. Now, the third one is temp. Temp, every file inside temp, as you can see, it is temporary, right? So it means that it will get deleted when you shut down the PC. So when anything you put in temp will be deleted after the restart or the shutdown. Now, the third one is /etc/sudoers. So sudoers, every user inside this group or this file will be able to use the sudo permissions on the system. /home, you will see the desktop downloads documents inside this directory. Okay, /root, you know, the root file system directory, and /user. Here you will see all of the software that's installed on the Linux package you have. Also, we have bin and sbin. This is for critical files. Don't try to delete anything in here. Now we have as well the var. Most of the time you would use var to host a web server. So var html to store or to operate, to store the files for the web server. Okay. So that was about the first part of Linux fundamentals. I hope you enjoyed this part. The next video, or later down the road, I will create another video to explain the advanced aspects of the Linux. So in this video, you can take all of the info that have been outlined here as an introduction, fundamentals that you can use in order to start in Linux or in order to refresh up on your knowledge. So let's now go to TryHackMe and answer the questions. So cd and make directory. Using relative paths, how would you cd to your home directory? So cd home directory. Using absolute path, how would you make a directory called test in temp? So make directory to create a directory, absolute path, meaning the full path, in temp, the file name is test. Okay, the links now. How would you link home test file to temp test? So ln, the source is home test file, destination is temp tests. Okay. Defined. How do you find files that have specific permissions? So we use -perm. No? And okay, let's use the man find. Okay, so we could use man find grep permissions. Searching file by permissions, files which meet these criteria but have other permissions, it's -perm. -perm. Actually, I forgot dash, that's why it didn't work. How would you find all the files in home? So find home. This will look in all the files in home. How would you find all the files owned by Paradox on the whole system? So specifying the user here. So find for issuing the command, the whole system using the slash, and specifying the user can be done with -user Paradox. Okay. Next one, grep. What flag lists line numbers for every string found? What flag lists line numbers for every string found? Okay, let's see the man pages. Man grep line. Line buffered -n line number. So using the -n. How would I search for the string boop in the file AAA in the directory temp? Okay. The string is this one, and in the file AAA, specifying the file 4 A's, right? 2, 4. Okay. Shiba 3, we've been through a lot in this section, and the challenge for this binary will reflect that. The first step is actually finding the binary. I'm not heartless, though, so I will give you the name of the binary. The name of the binary is Shiba 4. The actual binary will check for two things. We will be checking that there's a directory called test in your home directory. How you create that is up to you. It will also be checking that inside the file. Okay, let's do that last because the connection now is not working. sudo. How do you specify which user you want to run a command as? No. How do you specify which user to run the command as? So how do you specify which user you want to run a command as -u? How would I run who am I as user gen? Okay, so we'll type sudo -u gen who am I. How do you list your current sudo privileges? What commands you can run? Who you can run them as -i. Oh, -l. Okay. Adding users and groups. We haven't covered this, but it is very simple. You just use the add user to add a user, add a group to add a group, and here to add a user to group. How would I add the user test to the group test? So use the command user node -a-g. The group name is test and user name is test. Okay. This is done. And installing packages. So we still have the challenge. This one, there is a problem in the G, and here we have a processes. We haven't talked about processes actually. We will talk about the processes when I cover the advanced tutorial. But anyway, you can just display the processes with the PS, okay? And you can kill a process with the kill, providing the PID. The PID is a number displayed beside the process that's used to work with the process. But we will cover the process more in depth later. Okay, let's now see the challenge. So the challenge is, let's log in now to the machine. The password. Okay, let's read that one more time. So we've been through a lot in this section, and the challenge for this binary will reflect that. The first step is actually finding the binary. I'm not heartless though, so I'll give you the name of the binary. The name of the binary is Shiva4. The actual binary will check for two things. It will be checking that there is a directory called test in your home directory. How you create that is up to you. It will also be checking that inside the directory there is a file called test1234. So, and he is asking what is Shiva4 password. So technically, he is giving the requirement to answer the question. Make sure that you create a directory called test in home directory and create a file inside of it called test1234 and look for Shiva4 file, execute it, it will give you the password. Okay, so pwd, we are in home Shiva3. So make directory called test and create the file name is test1234 test ls. Okay, cd test touch test 1234. Does it have an extension? No extension. Okay, let's now look for the Shiva binary. Find entire OS -name Shiva4. Yep. Very overwhelming icons. Okay, Shiva4. What else? -type. It is binary, so let's use F as a file and use div null. So possibly we have two places. The first one is opt secret Shiva4, etc Shiva4. Let me execute this one using the absolute path. test 1 2 3 4. If I execute this one, permission denied. So I suggest I guess the test password test 1 2 3 4. No. Okay. What is Shiba 4 password? Test 1 2 3 4. Yes. Okay. So what is left is this one. It's not working. No. Let me refresh. Maybe something will change. So sudo usermod -a -g test. Okay, so that was the end of it.